Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en met mij is zoals altijd
Jan Stomporst, solution architect van ACC, powered by ACC ICT. Ik ben ook powered by ACC ICT.
Jij bent ook powered by ACC? Nou, wauw.
Je stem sloeg al over. Is het al zo?
Ja, dag 2 en het begint al. Regenachtig buiten. Dus
het koudje zit erin. Dus...
Ja, heb je het naar je zin, Jan?
Ja, we hebben ook nog gasten ook, hè?
Ja,
zeker naar mijn zin. Zeker. Drukte, leuke dingen. Interessant.
Ja? Oké, maar je wil naar de gasten, hè?
Ja, ik wil.
Okay.
Ik ben benieuwd.
So we go to our guests. We have Jannis Relakis and Michael McCarty. Welcome to both of you.
Thank you.
And Jannis, can you please introduce yourself to our listeners?
Yeah, sure. So I'm Jannis. I'm a senior platform engineer at Celonis. I don't know if you know Celonis. I didn't know it before I started working for the company, but it is a company basically that optimizes business processes for other companies. Our main field is process mining, as it's called. Yeah, I've been at the company for 3 years now. I'm originally from Greece, but I've lived in Germany for more than half of my life. Yeah, I live in Berlin now. A little bit about how I got into IT. I actually studied...
He knows our questions.
Yeah.
Awesome.
Well, I'm well prepared here. So I studied actually electrical engineering, which is not really the same as IT. And then I gradually moved into it. First after university, I had a startup. And the startup was about, we used to call it Industry 4.0 back in the day, but it's basically connecting production equipment to the internet and then visualizing the data and analyzing it and trying to optimize the production process. That was the idea back then. Inevitably, my startup failed. But I was the person in the company that basically worked with the cloud. This was the first steps we did on Azure back then. And I found it very, very interesting. I always had a knack for programming and coding myself. So I did that as a child and I then continued that. But then I realized during the startup years that I want to turn this into a profession. So I started working and, developing skills in that area and doing things by myself, which allowed me to land the job in IT, thankfully, as a DevOps engineer back in the day. And I've been in the space now for 9 years.
Cool. And then Michael?
Yeah. Hello, I'm Michael. Thanks for having us. So I'm also a platform engineer at Celonis. I've been with Celonis almost 3 years now. And I grew up in Austria, so where I spent most of my life. Then I spent significant time in Germany, where I also worked for different companies. And now recently I moved to the US, to North Carolina. And I got into computers and programming and stuff, I think relatively late, maybe 15, 16 and so on. And then I got really personally into Linux and programming and made my first self-taught experiences there. And then at some point I went to university. I studied, I would say, information security, but then and then I started out in the industry briefly as a Linux system administrator, and then later got into this cloud engineering, DevOps, Kubernetes niche, I would say.
A niche?
Where now I guess I'm for the last 12 years in it. And now I think both of us work really intensely with Kubernetes. And now we are here at KubeCon and had a talk yesterday, and that's also how we got to know you guys and ended up on this podcast.
That's true. And your talk is no shame, just pain, because you migrated from 1.16 to in 2025, so last year.
Yeah.
So can you give us a rundown of what you're talking about and how it came to be?
Yeah. So we maneuvered ourselves in a situation where we had a bunch of different Kubernetes flavors. And when I say a bunch, I mean 6. And so we had Gardener, for instance. We had Gardener AWS, Gardener on Azure. We had KOps clusters, which we managed ourselves, or COPS. I don't know what the right pronunciation. Yeah, what the wrong pronunciation is. But yeah, in any case,
Still wrong, but yeah, no. COPS clusters then.
Yeah,
but yeah,
yeah, COPS clusters where we managed the control plane ourselves. We had OpenShift, both Rosa and ARO, in case that rings a bell, which were supposedly managed. I have to be careful what I say now. So, but let's say we weren't so satisfied with the service. And yeah, so we had like a big zoo of different Kubernetes flavors, basically. And the talk was about our project to consolidate that zoo, move away from these different flavors and actually consolidated into the 3 flavors that we then chose, which is GKE, AKS, and EKS. And it's mostly about moving the workloads from the old clusters to the new clusters, what challenges we had, how we made it work in terms of networking, and a few lessons that we learned along the way.
I've gotten 5 questions. So.
Go ahead.
Raising a lot of questions.
So no on-premise anymore?
No.
COPS is on-premise.
Yeah, but no, it was COPS, but on AWS.
Okay.
Yeah.
And why did you choose then for, because you 3 different flavors and those are managed ones probably.
Correct.
And why did you choose then for AKS and EKS and
You said it, because we didn't want to manage the control plane. We chose to have, as little to do as possible. We choose to pay the premium to make our lives easier. Let's put it that way.
But still, you've got a lot of flavors, and I know from firsthand, if you do like an AKS cluster, you can choose the CNI, you can do Cilium or Azure, the Azure one, or do it yourself, or you've got flavors in there. And did you choose one CNI for everything, or what?
Yeah, I think that's maybe another level where we're also trying to consolidate. So I think you're absolutely right. EKS and AKS, they're not identical. Like we keep them on the same Kubernetes version. We keep all the cluster add-ons as much as possible in sync. But then there are, like, if you go into the details, there are of course differences. But then we try, for example, we use Cilium across everything. We have Cilium on EKS, Cilium on AKS, Cilium on GKE. But then they are also a little bit different because not exactly the same versions and configurations everywhere.
Yeah, and are you using then the managed ones, or are you managing your the CNI yourselves?
Yeah, we are installing Cilium ourselves from the Helm chart. Yeah.
Oh, from that, cool.
Basically, and then another thing I wanted to mention is also we also adopted Karpenter, which then also gives us like more or less identical node group management across these different flavors. But again, there are the differences in the details always.
Yeah, but it is much more consolidated and much more harmonized, let's say, than it was before. So for us, this is a gigantic step forward. So yeah, there are still differences, which I think are unavoidable. But still, we designed it from the ground up to be as similar as possible between the 3 cloud providers. And the reason we have 3 cloud providers, maybe provide some context for you to understand why that is in the first place. I mean, you don't need to do that, but in our case, we have customers that actually demand it.
Yeah.
They have credits on Azure, for instance. Or our customer is Microsoft, and then you cannot you cannot offer, you cannot give them a GKE cluster.
It would be so funny. Why is this performing so well?
It's not yours, that's why. So yeah, we have different reasons for needing to offer environments on the 3 big cloud providers. Yeah.
Can you give us a little rundown? Maybe you told it, but I missed it. How your environment looks like, how many clusters, because we now lie way high over in the cloud spectrum, but I'm also interested in how it looks a little bit on the infrastructure-wise.
Yeah, absolutely. So we call basically internally an installation of Celonis. We call an environment, and an environment can be multi-tenant or can be dedicated. So it can be just for one customer or many customers. And then when it's multi-tenant, then it's typically in one environment per cloud region. So like AWS US East 1, we just have one such environment, and then we put new customers into this multi-tenant environment basically. And yeah, so we have these different dimensions on which we need to create these environments. And last time we checked, we had like 150, 160 Kubernetes clusters that we are managing, which is why it's extremely important to us to keep them uniform, to have like, let's say, operations that really scale so that we don't need to add additional platform engineers when the company grows, but basically that this maintenance can scale non-linearly.
Right. Yeah. Okay. So 150 clusters. In your talk, you also talked about Wormhole. What can you tell us about that? Because that's the first time I hear. Are you familiar with Wormhole? Jan?
No, I know wormholes, but in which context?
Minimalist do-it-yourself cross-cluster service mesh. That's interesting.
Yeah. The wormhole is not something that's available as open source. It's like
maybe it should be though.
Maybe it should be. Maybe it could be useful to other companies.
You build it yourself?
Yeah, we build it ourselves.
There we go.
And it's like very specific and purpose built for our use case. And also we only used it during the migration from old to new clusters. We don't use it as a general service mesh or something. So, and basically allows us for the services to talk to each other no matter in which cluster they are running. So the services, like service A can talk to service B across the cluster boundaries, and they're actually not aware, or they don't need to be aware that the target service is running somewhere else.
Okay.
It's completely transparent. So the only thing we needed to do is to point the service to the wormhole, and then every service trying to call that service would end up in the other cluster, let's say.
So you're creating services in the old cluster that's pointing to an external IP address in the other cluster.
Kind of, yes.
And has then on that service, and that has pods behind that.
Yeah, that's correct.
Yeah, like pointing to an internal network load balancer.
Yeah. You've got the slides.
Yeah, I sent it to you.
Oh yeah.
Yeah, under the hood it's Envoy, and what's the feature called again that we're using that allows us to?
It's called dynamic forward proxy. So it's like a plugin or module, I guess, of Envoy. Mm-hmm. Where you don't have to know all the destinations in advance. So like when you're doing like a reverse proxy, typically you know what the destination is. But in our case, if service talks to another service in the same namespace, it just does like HTTP/service name through DNS. And dynamic forward proxying basically allows Envoy to do this name resolution on the fly. And so we don't need to configure every target. It will just find it on the fly. Yeah.
Okay.
Yeah. And sorry, I think I know what your next question is going to be.
Cool. I like that.
I mean, maybe not, but the question that I would have if I heard this was like, why not just switch everything at the ingress level and just point, like deploy everything, switch the ingress, and then you're fine. You migrate it, right?
Yeah.
The idea was, in our case, that we wanted to do the migration gradually. We have a lot of services that are owned by different teams, and we had a lot of different migration procedures. So most of them could be migrated as easily as I just mentioned. Deploy on target, cut over the traffic, and you're good. But there are other services that don't allow this sort of treatment, let's say. We have our in-house built in-memory database, for instance, and this needs a much more complicated migration procedure. And for us to synchronize all the teams to work on that one migration was an organizational overhead that was immense, and we didn't want to do that. Therefore, we needed a solution that allowed us to have the in-memory database team migrate first at a moment which is convenient to them, and then migrate the rest of the services at a different point in time. So we had complete independence how and in which order to move the workloads, which this is where the wormhole comes in. I move app A, but I don't move app B. I leave it there for a couple of weeks. But for app A and app B, this is completely transparent.
And did you not have a problem with latency then?
Not really, no. We didn't have any issues in terms of latency during the migrations, even on clusters that are enormous, that have like 1,500 tenants, for instance, and like get really a lot of traffic.
Okay. And maybe what we can add to that, I think it's closely related, is also the RabbitMQ piece. So we use RabbitMQ quite extensively. So we also needed to create the connection basically there. So create a federation between the RabbitMQ cluster in the old cluster and in the new cluster. And the way it works is basically messages in the queue can be consumed on either side. But if there's no consumer, let's say on the source cluster, because the application was already migrated, it will then automatically be available in the target cluster. So then the application can consume the message there.
Yeah, if you don't have a local consumer, it will be federated and it can be consumed on the other cluster.
And that works good.
That works really well, actually. We were also surprised, and I think it's a really cool feature of RabbitMQ. I think I didn't know about it before, but yeah,
cool. And what are the biggest problems you faced? You said you've got some lessons learned, and yeah.
I mean, we caused a bunch of incidents. I remember there was one. There was one early on where I personally synced an Argo CD application, which was where autosync was not enabled on purpose, and I synced it by mistake, and I basically tore down the connection between the two clusters, and that led to a full outage of one of our environments. And it was one of the biggest environments, and that was for like 10 minutes or so, which was a huge issue. But yeah, we learned, this might be a small thing, but we learned, this taught me at least, to put in guardrails, even for ourselves. Even, we're power users. We can escalate our privilege to go to have like God privileges, right? We can do that on our systems. But even for us, and even with the people that were really knowledgeable about the migration procedures, even we needed guardrails. Even we needed better guardrails than we had in place in the beginning of the journey, let's say. And the solution to this was, don't have an Argo CD app that is out of sync and is not supposed to be synced, because that leads to destruction, and do that through a PR instead, and have a CLI or an automation that creates the pull request that, can be then reviewed by a colleague, for instance. And this is just a small example of how we iteratively improved our processes, for instance.
Oh, cool. Cool. And do you have a story? I see you laughing.
Yeah, I was just like thinking about what would be interesting. I think one thing that was only like recently is because at some point we also want to delete the old clusters, right? And this requires us to be like extremely careful, make sure nothing is running anymore in the old cluster. No traffic is going through the old cluster.
That kind of moments.
and even then, I think at one instance it happened that the old cluster, let's say infrastructure as code, was still owning a security group rule. And then as part of deleting the cluster, this security group rule was deleted, but this still impacted the new environment. And these are like the little nitty-gritty details that are very hard to anticipate and can happen. And I think it was really quickly resolved, but still, it's almost impossible to have everything.
Everybody with like a system engineer background feels this pain, you know?
Yeah.
I've migrated everything. I'm sure nobody is connected. Every service is migrated. Turn it off.
Incident.
Your phone rings. You know what happened?
Exactly.
So how did you cope with 1.16 YAML versus 1.32 probably?
32, 33. Yeah.
Those are different. Ingress is different. What I can think more. There are some things deprecated.
Yeah. Ingress was relatively easy because we were using Ingress. So Ingress resources in the old cluster, but we got rid of them because we replaced them with HTTP routes because it worked differently in the new cluster. But there were other problems and there were other deprecated versions, but we had an automation that went through that, and for most cases it was able to resolve these issues by itself because the manifest didn't really change that much. So the schema of these resources didn't change that much. In some cases where it did, it just flagged it for us, the automation. So it said, hey, I found a resource which might have structural differences. Please have a look at it and try to fix it yourself. If I did this today with the advances in AI, probably I would have allowed it to do the change itself, to propose, a different solution or a fix, which I then would have reviewed. But we wrote this from scratch by hand. So
not Pluto?
Sorry?
You know the tool Pluto?
No.
That does it for you.
Yeah, okay.
Wasn't there also like that they switched from master to control planes back in around those version, that the naming convention was changed?
Convention of the control planes is changed.
Yeah.
Okay, we didn't run into this.
No,
we didn't run into this.
No, you don't have. If you just deploy applications, you don't have anything to do with that. But did you do the new things like PDBs? And
PDBs we had also in 118.
not on 116.
116.
Sorry, yeah, 116.
Are you sure? Like,
Yeah, we had the PDB.
I think we already had PDPs.
Yeah, we had the PDB. We have a PDB controller that is running also on our old clusters. I'm pretty sure. So
Yeah.
Okay.
Yeah, and also maybe to add, not all of our clusters were on 116. So even before the migration, we already needed to differentiate like different cron job API, different HBA, which actually made our lives miserable, and this is one of the reasons why we needed to migrate, because we had to do things differently on different clusters, and now we can do it in a unified way.
The most custom logic we had in that automation, and the most ugly logic, I wrote it, so it's my fault, but was everything that was related to removing OpenShift specific stuff. Because you have like shared volumes or security context constraints and stuff like that are, these are OpenShift concepts and they don't exist on AKS, EKS, GKE. And we needed something that either translated those, like in shared volumes, you translate it into PVC and PV and stuff like that. In SCC, we removed it because we had other mechanisms in place. But we were using Customize, and we had like OpenShift overlays. So we needed a logic that removed these overlays from our the overlays we inherited, the OpenShift specific stuff from our Customize, and that was complicated to write and complicated to maintain. And it was pretty ugly code, thankfully. We can throw it away now and we can forget about it. So
it was a fun adventure.
Yeah, for sure.
But in another way, you could also do an OpenShift cluster on 3 clouds.
Yeah, we're not. We're using vanilla Kubernetes. So.
And what was the biggest holdback to use not OpenShift on those 3 clouds? Because then you would have one flavor everywhere.
But I think because we already experienced that, and in reality, it's still multiple flavors. Like we said, we used Rosa, so Red Hat OpenShift on AWS or whatever it's called, and then the equivalent on Azure, and in the details there are still differences. Like, for example, OpenShift on AWS has these node pool abstraction, and then they have the machine sets and machine autoscalers and whatever. And on Azure, there's no node. I think it's node pool abstraction, and so they are, for us, we treated them as two different provisioners because there are so many.
Yeah, and you're bound within the tools of OpenShift, right? So it's not like you have the latest version always.
Honestly,
but that thing is
between the clouds.
That thing is you deploy it and on every cluster, and you should have everything the same.
Yeah, you should.
Yeah.
Honestly, I would say OpenShift on AWS and OpenShift on Azure are as different as EKS and AKS. So I don't think it would have made our lives much easier.
Right. Well, we have Red Hat later on.
We'll ask
them. What's happening there? You also mentioned in your presentation, beware of the scope creep. Is there some?
Yeah, I can speak to that a little bit. I remember in the early stages of the project, because we were starting this massive journey, moving away, migrating so many clusters, people were coming in there and they were like, okay, can we also do this?
Yeah.
Can we also do that? Can we add to this? I also have this great idea.
You're getting in the flow, right?
Yeah.
You want to add.
I also have this great idea about, moving Argo to this, or I don't know, sharding Argo. Or
this guy on Reddit says this. Maybe we should try it.
Yeah. Pre-rendering manifests. I remember we had an initiative. We called it GitOps version 2 internally, whatever, which was about restructuring how we do GitOps, which is not really related to the migration at all. But for instance, it was bundled all together. And that made everything harder. It made the project meetings harder. It made coordination harder. It made understanding and reporting to management harder because you didn't have like a focus. Yeah. And so at some point we were like, no, this is big enough of a scope as it is. It is big enough of a project as it is. So let's only do the essential, which is moving the apps from old clusters to new clusters and moving them to an infrastructure that is as consolidated and as, harmonized as possible. And that's it. Everything else is out of scope.
And every additional variable that you to the mix increases the chance of things going wrong and incidents happening. So, and that was already like enough potential of that. So it was also big reason for that.
Because is that the same thing as snowflakes will slow you down?
No, I would think this is a different issue. So Snowflake is what we call internally just a special environment. So for some reason, I mean, it has usually like historically grown that, for example, the Kubernetes manifests look different on one cluster, even though it's the exact same flavor. And then our automations would suddenly not work anymore. Or the runbooks that we have created that worked on the free previous clusters would now suddenly not work anymore and fail. And then we have to investigate and put in the hours again to fix it and update it. So that's what we meant by the snowflakes.
So do you add a lot of snowflakes then? Or because that's slowing you down. So you needed to change more for your snowflakes.
Yeah, definitely. Maybe there were always like smaller differences along the way, but maybe the most prominent ones were we have one environment that needed to be HIPAA compliant. So we had Istio there for like service-to-service MTLS encryption, which we didn't have in other environments. And then also for that environment, we needed to make sure that the traffic in transit is also encrypted through the wormhole. Like even though it's all like on the VPC peering, it's not going through the public internet. So we had to make changes to wormhole, and
even RabbitMQ and the federation needed to be set up in a different way. So the migration procedure itself changed because of the snowflakes that we had. But it was also, even within certain provisioner, we had differences in how we had set up our environments. And sometimes we would say, oh, we are running into the system and we know that, or we are about to migrate this system and we know that there are certain differences. So we reserved extra time because we knew that this migration would take longer. We knew that we would have to maybe adjust our automation a little bit here and there to make sure that we account for these differences. So this definitely slowed us down. And this is another advantage of this migration, of having done this migration. We consolidated as much as we could. I mean, yesterday after the presentation, actually, we had a question and they were like, okay, you consolidated, but you didn't get rid of HIPAA, did you? No, but we tried to set up things in a way that everything is HIPAA compliant.
Yeah.
And therefore, you don't have these differences anymore, which makes your life from day to day, in day to day, much, much easier.
Go the most restrictive version and then the rest
Exactly.
follows.
Exactly. It's actually cheaper to do that than having to manage two different setups.
Another snowflake I can just think of is we came across an environment that was actually already migrated one time before for different reasons. And then, so for example, in the migration, we used like static persistent volumes to connect to the same storage, like EFS in this case. But then in this specific environment, there were already persistent volumes in Git. So our automation didn't know how to handle that because that's what its job. But now this environment looked like it was already migrated. So then that were also times when we needed to step in and do manual changes.
Yeah.
And that, massively slowed us down.
Yeah, I think it's up for our final question, Jan. So I give you the honors to ask the final question.
I can do it. So if we have a crystal ball on the table, it's your line. How do you see the future of Kubernetes?
How would you like to see the future?
Oh, yeah. Also.
I think I'm going to answer this with a very specific answer because
you like that.
I'm working on a big FinOps project now where we need to cut some of our costs of our infrastructure. And I realize, at least I notice, many companies popping up that help you scale, right size your workloads, and make sure that you don't use more resources than you need to. And I would like, and I think this in the era of AI, this becomes even more important. And I would like to see some of these features offered by these vendors actually end up in Kubernetes itself. So because I don't think that vertical pod autoscaler is the ideal solution the way it works right now and in today's economy, let's say. So I would like to see a lot of the features that these companies offer be integrated within the Kubernetes project.
Okay, cool. But is the vertical pod autoscaler not a band-aid or a sticker to fix something what should not happen?
How do you mean?
Vertical pod autoscaling can increase your CPU and memory on the fly nowadays.
Yeah.
But why?
Why not? I mean,
then your application is not Kettle anymore, but it's becoming more pet. And we want to go to Kettle. So I know it's why they're doing that, because it's for stateful workloads. But I prefer to Kubernetes is built as Kettle, to keep everything as Kettle. And now we're doing a band-aid for vertical pod autoscaler to accommodate stateful applications and maybe VMs or.
But I mean, the reality is that at least at the companies that I've worked for, there are always stateful applications. This might not be the ideal solution, but in some cases you do need it, I guess. And you have to account for these. So it is a band-aid, you might be right. but it's necessary, at least in the real world where I'm coming from.
Yeah, awesome. Awesome. And you, Michael?
So one area where I really hope that things will improve in the future, like right now, there is like this clear separation of workload scheduling and node scheduling, and the two things are kind of out of sync. Even like in the age of Karpenter, it's really challenging to optimize your resource utilization, like bin packing. So, and there, like it's already quite many years ago when AWS introduced Fargate, so that you have this like lightweight virtual machines, so that it's almost like you have only one pod per node, and then you can really tailor the resource requests to the underlying hardware and more like abstract from the like instance types and stuff like that.
More like serverless?
Yeah, kind of, but I think that's a good point. Maybe more in direction of serverless while still keeping a lot of the benefits of the Kubernetes ecosystem around and the great API it provides and CRDs and the sort of controller paradigm. So, yeah.
But do you need that? Why should you need that? Yeah, just thinking through. Why do you need that in the future? Why should I need to have CRDs and the API of Kubernetes when I'm doing serverless or such kind of workload?
I mean, you're still gonna need your databases and your CDNs and all your other resources that you can still provision through one unified API, I think.
Okay, cool.
But I mean, the fact that Kubernetes is still around and still stronger than ever, even though serverless is also around for such a long time, shows that there's still very much a need.
It dwindled a little bit to the background, right? So you don't hear it like as often as like 2 years ago.
It's now AI.
Or is it just our Kubernetes bubble we're in?
Yeah, it could be.
No, you don't hear it that often anymore. But I'm still wondering why not?
Yeah, don't ask me.
So, thank you very much for
Thanks,
your
guys,
time.
for joining us.
Yeah, thank you for having us. It was a great experience.
Yeah, thank you.
Great talk.
But-
Thank
Okay,
you.
Thank you.